Good morning. Today we're going to be covering dimensioning, and I have two PowerPoints I want to cover. The first one actually falls much later in the curriculum, but some of the terminology in that I think would be useful now rather than waiting to get to that. And then we'll talk about the rules that we will use to govern the way we place dimensions on hand drawings, and then dimensions in Inventor as well. So let's start with dimensioning standards. A dimension is made up of four parts. First one would be an extension line. Extension line extends out from an object, in this case on either side, and there's a little gap so it's not actually touching. It's a little bit lighter than an object line, so it's not as dark as an object line. That's the extension line. And then connecting between extension lines on either side is a dimension line. On the dimension lines where you're going to place the dimension. There are arrowheads on either side, and then typically your dimension text centered in the middle. So there are four parts that make up a typical dimension on a drawing. If for some reason the number or the dimension text that we're placing on the drawing doesn't fit between the extension lines, typically we'll move it out on the outside, right? So my arrows are still in the middle at my dimension line, but instead of breaking the line and putting the number in the middle, I'm moving it to the outside if it's not going to fit. The dimension text can be placed in the middle line both horizontally and vertically, right? So this number is in the middle horizontally, and then same thing, the distance up and down vertically, typically. So there are two methods for placing dimensions on the drawing as far as the alignment goes. The first one would be a unidirectional method, meaning that all dimensions are read in the same direction. The other way would be an aligned method, which means the dimensions are read in alignment with the dimension lines or the side of the part. Some are horizontal, some are vertical. So let's look at examples of that. This would be the unidirectional method of dimensioning. Notice all the numbers face the same direction. If I were holding the page, I could read them all in the same way. The other method would be an aligned method, where the dimension or the dimension text is aligned with the dimension line or the side of the part. More often than not, that we're going to use a unidirectional with the drawings that we do. This would be more common with an architectural type drawing like a blueprint or a floor plan. Okay, so this would be probably the method that we're going to use most often within this class. Classification of dimensions, there are two types. It's either a size dimension or it's a location dimension. The size dimension is going to be used to identify the specific size of the feature of your object, as compared to a location dimension, which is used to identify the physical proximity of a feature to another feature within an object. So let's look at an example here. A size dimension is going to give me the size of something. So if I'm looking at this slot here, from the two center points on the slot, I know that the size is 1.83. They're 1.83 inches apart from each other. Now, if I wanted to locate the placement of this slot on my object, I would use a location dimension that tells me that this center point is located 0.61 inches away from the top of the object. So it only falls in two categories. It's either a size dimension or it's a location dimension. Okay. And then let's talk about the ways that we can place dimensions on the drawing. There's a couple ways. Chain dimensioning happens when I dimension from one feature to the next feature and they're kind of in alignment with each other, which is why it's called chain dimensioning. Method one shows this as an example. So I have 0.5, 0.5, 0.5 showing all the features in a line. That's chain dimensioning. The second method of doing the same thing is to have an overall dimension, giving me that overall size, and then chaining some of the other ones. This has been left blank here intentionally, because if I have the overall size, I know this is half an inch and half an inch, I can figure out what that distance is as well. That's going to come in when we talk about the rules, which will be the next PowerPoint we do. Okay? So this would be the preferred method of doing chain dimensioning, is to have the overall dimension included as well. Another way is to do datum dimensioning, and datum dimensioning happens when you place dimensions from a single point or origin. So they all reference back to that same place. And this is the way typically that I place dimensions on drawing. It's going to reduce the number or the amount of dimensional deviation in manufactured parts, because size and location dimensions reference to a single point. So as an example, if I'm looking at this object, the front view, each of these dimensions are referencing that same edge. Right? They're all coming back to the same edge. In fact, they're sharing the same extension line. So this is called datum dimensioning. Either method works, so it's up to you on which way you want to do that. All right, let's jump to the other PowerPoint. That was kind of the basic terminology and an intro. Let's talk about the rules then that will govern the way that we place the dimensions onto our drawings, whether that's a hand drawing or whether that's on the computer software. So number one, dimensions should reflect the actual size of the object, not the scaled size. Okay? Sometimes our drawings are too big to fit onto the standard sheet of paper, and so we're going to reduce the size of the drawing to fit, but we're not going to reduce the size of the dimensions. Notice that this is measuring at 3/4 of an inch, but we're showing the true size of 2 inches here. Number two, include overall dimensions in the 3 principal directions, which would be height, width, and depth. So we have to include at a minimum the overall dimensions on our drawings, height, width, and depth. The overall dimensions should be placed the greatest distance away from the object so that the intermediate dimensions can nest closer to the object. So if I look at the overall width of this front view at 2 inches, it's saying that this should be placed farther away from the object so that these dimensions don't cross through each other. So as the dimensions get larger, they should become farther away from the object. So anything in red here can be corrected by moving them farther out. Include all dimensions necessary to produce or inspect the part. If I'm the person that has to make this for you and you give me this information to build it, I need to have all the dimensions. I don't want to guess on the size or location of parts of my object. You don't want me to do that either, right? So in this case, I'm missing dimensions here and here. I need to add those in to complete this drawing. The flip side of that is, though, I don't want to put too many dimensions on, right? I need all the information necessary to produce or inspect the part, but no more than that. So dimensions should not be duplicated or the same information given in 2 different ways. If I look at this example here, it's very cluttered. There's a lot of dimensions on the drawing. To reduce that, I'm going to get rid of information that's been duplicated. So this front view has an overall width of 2 inches. Well, this top view is describing the same object. Do I need to show that the overall width, again, is 2 inches? No, it's the same information. So in this case, all dimensions in red have been shown somewhere else already on the drawing and can be eliminated, right? So it's showing this is duplicated with that. My overall height is duplicated with this one on that side. Second part of that, do not include chain dimensions that add up to a given overall dimension. So we talked about this in the previous PowerPoint. If I'm doing chain dimensioning and I have to include the overall dimensions, then I don't want these to add up to this number. I'm getting to the same thing. So I can leave one of these dimensions off as part of the chain because I can determine, based on the overall, what that size is. So in this case, these ones here in red can be removed because it's duplicate information or has been shown in a different way. Dimensions should be attached to the view that best shows the contour of the feature to be dimensioned. We did talk about when we were doing the puzzle cube project that the placement of the front view is important. The front view is going to have the best contour and shape of the object, which means that most of the dimensions then will also go in the front view. These are not incorrect. These sizes are correct, but it would mean more or show more if they were on the view that showed that contour. So everything in red here can be moved to my front view, and that would be the proper way of doing that. The dimensions should be attached to only one view. For example, the extension line should not be connected to 2 views, right? So my number 1 here and the number 1 here, this extension line and this extension line are for the same object, and they should not be connected that way, right? In Inventor, it's probably not going to let you do that anyway, but while we're doing this by hand, make sure that that is the case. So these ones are incorrect. I would correct them by making sure the extension lines connect to the same object. Whenever possible, locate dimensions between adjacent views. The adjacent views means that I have, the space that we left in between the views specifically for the purposes of adding the dimensions. So rather than pulling these extension lines through the feature to put it over here, if I move it in between adjacent views, it wouldn't do that. And it's referencing both views. The overall width of 2 inches here is the same 2 inches here, so it would be preferred to have those placed in between the adjacent views. Avoid dimensioning to hidden lines. On my right view here, I have a 0.75 that's indicating the location of this hidden line. It would be better to create or place the dimension on the view that's creating that hidden line. Right? This part that's been cut out here is what creates the hidden line on this right view. It would be best to put the dimension over here. Notice that it says avoid. It doesn't mean never, ever, ever. It says avoid. So there are going to be circumstances where we have to put a dimension to a hidden line. But for the most part, we want to try to avoid doing that. Do not place dimension lines on the object unless it's absolutely necessary. So we really want to avoid putting them within the object. We don't want to use the object lines as the extension lines. And so these ones here in red are going to be moved out from the object. Do not cross a dimension line with another dimension line or with an extension. We already looked at this in kind of the first example. It's simple to fix. If I make sure that the larger dimensions are farthest away from the object, then they won't cross through each other. Avoid crossing dimension or extension lines with a leader line. I haven't mentioned what a leader line is, but it's located right here. A leader line is used to to place a dimension on, in this case, a hole in this object. And I don't want this leader line to cross through my dimension or extension line, so to fix that, I simply move the leader line to a different location, and it's no longer crossing through it. A leader line points towards the center of the feature and should not occur horizontally or vertically. So on this side, which is what we want to do, my leader line is at an angle and points to the center of the feature, and it's giving me my diameter. We want to avoid the leader line being completely horizontal or completely vertical because we don't want to confuse that with either a center line that marks the center of the circle or extension line from another dimension. Dimension numbers should be centered between arrowheads except when using stacked dimensions and when the numbers should be staggered. So in this case, it's hard to read the dimensions because of the fact that they're all centered on our dimension line. So it's okay in this case to then stagger the numbers so that we can read them better. Right? It's no longer centered, but that's okay because it makes the drawing more legible. In general, a circle is going to be dimensioned by its diameter and an arc by its radius. So if I have a complete circle, I'm using the theta symbol and showing the diameter for the dimension. If it's a partial circle or an arc, I'm using R and then showing the radius for that. Holes should be located and sized in the view that shows that feature. So my hole is on the front view of the object. The dimensions for that hole should go on the front view of the object. I have hidden lines that represent the hole in the other views, and I don't want to put the dimension to the hidden lines. So I'm going to move the size and location dimensions for the hole onto the front view. And then finally, holes are located by the center lines, which may be extended and used as extension lines. So this is a center line that's used to mark where the center of the circle is. It's drawn with a long dash, short dash, long dash. And I can actually extend these out to make them extension lines and then use those as part of my dimension. In this case, they're location dimensions to locate where the center of this hole is. Okay, so we're scratching the surface. That's an intro to the rules that we're going to use. I mean, if you're in college, there's like books and pages of information and rules and standards. We're just going to focus on these 16 as we apply them to the activity that we're starting today. So we're going to be doing activity 3.4 linear dimensions. This is something that we will do directly in the notebook. So let's talk about kind of the expectations for that. For this here, it's asking us to do a multi-view drawing, and I already have the front and right view given, and then add the proper dimensions for that drawing. Each of these drawings is going to have a different grid spacing, so make sure that you're aware of that. The grid spacing in this first one is 0.125 inches. So each of these is 0.125 inches or 1/8 of an inch. So with the front view drawn and the right view drawn, then I have to determine the number of dimensions I need for this drawing. There's a tendency for students the first time they're doing dimensions to place a dimension for every single line. We don't need to do that. In fact, it's going to be over-dimensioned. We're providing too much information or duplicate information. So the next logical thing is, well then, how do I determine the proper number of dimensions for this drawing? Right? If I could give you a number, that might make it helpful for you to figure out, do I have enough dimensions? Have I put too many dimensions? So there is a way to do that. If I look at this drawing, I know that at a minimum, I'm going to need 3 dimensions, the overall width, height, and depth. So as a minimum, every drawing has to have at least 3, overall width, height, and depth. Okay. Now let's focus on on, let's say, just the width of this object. How many dimensions do I need that are going to be associated with the width? And I can determine that based on the number of changes in the contour. So starting from here, this is, let's say, 0. I have 2 changes in the contour here. So I need 2 dimensions associated with the width. When I'm talking about the height, there are 2 changes, 1, 2. So I need 2 dimensions associated with the height of the object. So I'm up to 4 now, 2 for width, 2 for height. And when I look at depth, there's only 1 change. So I need 1 dimension associated with the depth. So in total, I need 5 dimensions on this drawing. If I have fewer than 5 dimensions, I'm missing information. If I have more than 5 dimensions, I've duplicated information that doesn't need to be on the drawing. Let's look at the next one and try to figure out the same thing. Again, the spacing has changed. It's 4 millimeters now for each of these, so use that as the actual numbers. Let's determine how many dimensions we need then for this drawing. I've placed this as a multi-view in the notebook. Starting with the overall width, I have 1, 2, 3 changes, so that's 3 dimensions. 1, 2, 3 for the height, so now I'm up to 6 dimensions. Then 1, 2 for the depth, so 8 total. So this drawing needs 8 dimensions to be complete. We use the same logic for each of these, kind of work through each of the 5 drawings that are associated or been placed in this activity, and then there are 3 conclusion questions at the end. And you can do those either on the Word document or you can put them in your notebook along with the drawing. So I'll give you a couple days to work on this, and then when you're done, you can submit that on the LMS. Once we finish this activity, we're going to go back to the Puzzle Cube project and then apply the dimensions and the standards that we learned in this activity to the drawing sheets that we set up with the Puzzle Cube.